Tell me a little bit about your work at Hortonworks. What's the most exciting project you guys working on right now?
The most exciting stuff we're working on right now is inside Project Stinger.
Mm-hmm.
There's two exciting things. I'm going to erase this diagram.
Yeah.
Or try to.
It's style if you have multiple layers. Yeah.
Yeah. So inside Project Stinger, there's two really exciting things we're doing. One is on the storage and access to data layer. It's orc files and vectorization.
Mm-hmm.
Super exciting and will help anyone.
That's Owen's child, yeah?
Owen, actually, no one...
No?
He never wants to admit it, but orc is called optimized RC. In reality, it's Owen's RC.
Okay.
But he's not arrogant, so he doesn't.
No,
like
he's
that.
not. No. I know Owen's very well. Yeah.
But so on the storage side, it's orc files and vectorization on top of those orc files, and then on the factoring side, on the architecture side, it's projects Tez and Yarn.
So now Docutting would come in and say, orc, I can do that much better with
Parquet. So,
jump on that.
Sure. So at the end of the day, ORC is a format contributed by Microsoft's super geniuses inside the PDW team. These are actually guys who have spent, in some cases 30 plus years in data storage formats for relational workloads. ORC has some things that are just superior to anything else on the Hadoop platform right now.
Like
block level indexes.
Okay.
And type aware indexes. So it's a columnar format. I'm not going to bother to sketch up what a column... Maybe I should.
Yeah.
But, I mean, if you have a block like this, you really want to store all column 1 values, and then all column 2 values, and then all column 3 values. So typically, you call this a columnar store.
Yeah.
Some advantages we get, and most columnar stores, all columnar stores do that. That's not interesting. Advantages you get is you can take column 1 and compress it.
Sure.
Because now you have
better compression.
Most likely better compression because you have more consistency across value space.
Yeah, and luckily, very frequently, Hadoop files are sorted, so even better compression.
Exactly.
Yeah.
Like you take a web log, and this would be IP address, this would be access port, this would be browser type, right? And browser type is going to be what now? It's going to be
1 or 2
it's
or 3 or 5.
It's going to be Chrome or what is it called? Chrome or Safari or Internet Explorer, and that's it.
No Internet Explorer anymore.
So what we're columnar, and we can actually handle columns where the individual record sizes are quite large. We're type aware, which means you tell us if this is an int or some kind of numeric value or a long. You tell us that this is a string, and then we start doing things that are type aware. So we're SQL and Java type compliant, which is superior to anything else. But then we have an index as part of each block.
Okay.
And so they're stored contiguously.
Even navigate the block much faster.
Yeah.
How big is the block size?
It's configurable, but a good block size is like a gigabyte.
Okay.
Yeah.
Okay. Well, then it makes sense to have a index in front.
Yeah. So for example, a string index would be a dictionary.
Right.
So we dictionary encode strings, and we write all the unique strings up in the index. We compress them down, and then we write an integer lookup.
Yeah.
So
makes sense.
If you have things like URLs, they repeat a lot, and the URLs are actually going to just be URL 1, URL 17, URL 22, URL 33. Integers, we're going to have min, max, average, things like that. Per block.
Okay.
Date, we're going to have start date, end date.
Yeah. Okay.
And so
we find that small and really fast.
We find that we go, and then what you can do then is you can basically use the index to skip a block.
Yeah.
So when you're doing what? When you're doing filters and aggregations, you want to basically say there's a where clause, there's a query predicate. I can apply the query predicate to the index.
Right. And you don't even need to
Right. And I don't even need to hydrate the rows or columns at all.
So a row is the slow part, the deserialization, the inspection.
If this is row 1, this is row 2, this is row 3. Vectorization is the classic Java loop. With my, with my connection, I get a result set. And while result set dot has next, then result set dot field 1 dot field 2 dot field 3 next result. In a while loop, that while loop kills performance because you're iterating through a result set and you're paging data from various large RAM pools into processor L1 cache.
Right.
And what we're doing in vectorization is saying, leave this block dehydrated, flattened, unmarshaled as a block. You can look inside the index as much as you need to. And when you do pass it across the block, vectorize the query predicate. So turn the query predicate into scalars and then pass it across this as a mask. So you're basically looking at a giant set of ones and zeros.
And you basically just
and you're saying, I'm looking for the following pattern, 1011. And it says there is 1011. And then you say, oh, well, I want 1011 this way. And it says, okay, I see it right here. It's row 23.
Yeah.
And then you pull out row 23.
And then you even don't need to
So I'm moving a gigabyte at a time through the data. Obviously, L1 caches are on the order of megabytes. So to move a gigabyte into a megabyte L1 cache or a 16 meg L1 cache will take you hundreds of clock cycles or a few thousand clock cycles, which means it'll be done in under a second.
Yeah.
And we literally found a single laptop could manage a terabyte search in under like 2 seconds.
Nice.
With vectorization. So the org file is tied to the vectorization, and the org file is tied to a lot of stuff we intend to provide to technologies like Datamir on top of us, which is this global level index. Because if we take these indexes, you can use them now to show people ontologies about their data. So I have a column, I know its name, I know its type, and I know its value range. Like, I can bring the dictionary forward into Datamir. I can bring the integer min-max data timestamp values into Datamir, and that becomes dimension data or ontological data that's very interesting to the end user. Even though the system doesn't know what it is, it's very interesting to the end user. I can use it to speed up searches because I can skip blocks. So really what we're talking about is take that index, centralize it to the entire table space or data set, if you will, and then proffer that up to anyone who wants it. Now you can build systems that actually service queries without ever looking at a record at all.
So
and by the way, you paid no price to compute it except on ingest. You laid out
that will be my next question.
Price.
That will be my question on how is that impacting write performance?
So you're packing a gigabyte block, you're consuming some extra memory, and you're type aware, so you're marshalling the types on write down into disk. Our write performance for an org file needs to get better. But right now, we have tuned it, so it's faster, I think, to write an org file than an RC file, for example.
Okay. Well,
and an RC...
That wasn't great. Right? It's always the question of who you perform with, right?
Yeah.
RC file wasn't great.
Well, we've benchmarked org file writing against anything we can get our hands on. We find the best things out there we're competitive with. Well, I don't even want to name specifics, but I don't see a problem I see a problem in performance relative to an absolute number I'd like us to get to. So we can write tens of megabytes a second across a cluster. I want to write hundreds of megabytes a second, but no one is writing that fast right now. So.